Hi students. Today we are discussing about what is the difference between interference and diffraction as well as Fresnel's and Fraunhofer diffraction. Okay, and see. So there is a difference between Fresnel's diffraction and Fraunhofer diffraction. What was that? Let us see. So in Fresnel's, for diffraction to occur, the light source and screen are at finite distance from the obstacle. So the distance between the source and the screen should be finite. Where you are taking the Fraunhofer case, for diffraction to occur, the light source and screen are at infinite distance from the obstacle. So here is the distance between the source and screen, and here the distance between the source and screen are at an infinite distance from the obstacle. Now, the wavefront undergoing diffraction is either spherical or cylindrical. So, the wavefront undergoing the diffraction pattern will in the spherical or cylindrical. Now, in this, the wavefront undergoing diffraction is a plane wavefront. So, there is a difference between this is spherical or cylindrical, and here we are obtaining the plane wavefront. And here, no lens is used to focus the rays. You should remember that in case of Fresnel's diffraction, we are not using any lens. In case of Fraunhofer diffraction, we are using a converging lens. There is a convex lens. Here is the converging lens is used to focus the parallel lines. And next, either a point source or an illuminated narrow slit is used. Here we are using a point source or a slit, and here the extended source at infinite distance is used. The source is extended, has a infinite distance. And now the diffraction pattern can be studied only along the wave propagation direction, and it is complicated. So here we are also studying the diffraction pattern because of the propagation of wave direction, and it is complicated. And here the diffraction pattern can be studied in any direction, and it is easy. Here we are studying the pattern, that means diffraction pattern in any direction we can very easily. And next, this is the simple difference between the Fresnel's and Fraunhofer diffraction. And next, what is the difference between interference diffraction? The main topics in this unit is the interference and diffraction. Let us see what is the major difference between these two. Superposition is due to the two separate wavefronts originating from two coherent sources. For this interference, we are having two sources, and those should be coherent, and those are from two separate sources. The superposition is due to secondary wavelets originating from different parts of the same wavefront, because here for interference we are using two separate wavefronts from two different sources, and here we are using the secondary wavelets from same source, that means same wavefront. Now the fringes normally have equal widths. In interference, the fringes have equal widths. The width between fringes is never equal. According to the diffraction, we are obtaining here also fringes, but those are not in a equal width. Okay, and all the bright fringes have the same intensity. In the interference concept, we are obtaining alternate bright and dark fringes or darker rings. The intensity of bright fringes have same, that should be same, and here the bright fringes usually decreases with increase of order, and as the order may be increased, the intensity automatically will decrease. All the dark fringes have zero intensity. Dark fringes ultimately have the zero intensity in the interference pattern, and here the intensity of dark fringes is not zero. In the both cases, we are having an interference pattern and diffraction pattern, and the fringes have zero intensity. The dark fringes have zero intensity. Even in this case, the diffraction, the intensity of dark fringes is not zero. Okay,